Right. Good evening, Uday. So, we were discussing the pure solids. Patta easy lesson. There is nothing to understand, right? That is very easy. Correct? Right. So, in last week, we discussed about the octagon, right? And dodecahedron, right? So, then today we have to discuss icosahedron. Correct? That is another solid that you have to deal with in your grade. Yeah? When it comes to grade 9, normally this solid lesson will be disappeared. So no need to worry. This solid lesson will be disappeared, right? From your grade 9. Right?
Excuse me.
Only grade 7 and grade 8. 6, 7, 8. Only those grades. And after grade 9, solids will be disappeared, but there will be some similar lessons to this. We are going to apply some methods on solids, right? How to do the calculation, so on and so forth. Right. So, first of all, take the solids tube, and we are going to discuss some. We are going to discuss the properties about of icosahedron. Icosahedron. Right. That is in page number 4. Page number 4. Right. අපේ තව කට්ටිය අඩුයිනේ චිරත් නෑ ඉරුෂේ ඉන්නවද
Yes, sir.
Senoli yes Parath is not here, right? Janani ඇවිල්ලානේ after long time නේ Janani, right? Alright, okay buddy. So let's do this, right? Take the solid tube and turn to page number 4, and we are going to do this one, and let's end the lesson, right? Then I hope you guys have the paper with you. Paper number 1 that I gave you. I hope you have it, right? And I hope you have already completed that one as well, right? And we discussed paper number 1, part 1. Part 1 right? Then we have to discuss the paper number 1, part 2. Paper number 1, part 2, right? Essay questions, right? So first of all, we are going to finish this, then paper, then after that I am going to begin the next lesson, factors, right? Let's see, right? Okay, so first of all, icosahedron, right? This is under the solid lesson, right? Right. So the first of all, we have what is a regular. What is a regular icosahedron, right? Right. So in last week also we did the same thing, right? For our octagon, right? And for our dodecahedron, right? So when it comes to the icosahedron, right? You need to remember, right? In the solid icosahedron, right? You have equilateral faces, right? Equilateral triangular faces, right? Equilateral triangular faces, right? Remember that. You have to keep it in your mind. Equilateral triangular faces. How many equilateral triangular faces you should have in an icosahedron? 20, right? There are 20 equilateral, right, triangular faces in this solid. That is the most important point you need to remember, right? Under this solid. Right? Okay, so there is a, there I have given the introduction and let's fill the blanks, right? So to fill the blanks, I will use my red color pen, right? Right. A solid object which has, right? A solid object, I will write it in the board, right? So a solid object which has, so you have to fill the blank with it, right? A solid object which has 20 equilateral 20 equilateral, write down 20, yeah, in the blank space. Equilateral triangular faces. What is the shape of the face? Triangular faces is called a regular icosahedron, right? Regular icosahedron, right? So fill the blanks. Let's fill in the blank.
Excuse me, sir.
Oh, we message Oh, we can.
Sir, I only have factors tube. I don't have solid tube.
So, can you write this?
Okay, sir.
Only we are going to discuss this one, right? We have only this solid, right? And do you have the paper? I have sent it to the group.
No, sir.
Oh, why is that? Actually, this here, right? Write with it. Please write. So we have 6. This paper is only for an hour. Right. Yes, to the most of the schools are having 1 hour paper in this time. As your first term, right? As your first term exam, most of the schools are giving 1 hour paper, right? Sometimes you have to go through your last few lessons of your grade 7 as well. Last few lessons of your grade 7 and completed lessons in grade 8 up to now. So you have to go through them for the first term. Most of the times, I think your teachers will be focused on those lessons. They are going to focus on the last few lessons of the third term of grade 7, right? And the lessons that you have already covered up to now in grade 8. So the focus on them. So you can score. Right. 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 So this is it. So special character. There are special characteristics we need to know. There are special characteristics we need to know, right? When we are dealing with icosahedron, octahedron, and dodecahedron, then the solids that we have discussed in last week. And under this one as well, we have 4 characteristics like we discussed in last week. So same 4 characteristics you need to know with the values. Alright, you need to know with the values. Alright. So what are the values that we need to know? First of all, the first characteristic is I will tell, right? So Buddha, now we are going to talk about characteristics. You need to remember these things, right? Characteristics of a regular icosahedron, right? Regular icosahedron, right? So Buddha, what are the characteristics? There are 4 characteristics, right? So you need to remember, right? So first one, there are, right? There are 20 phases. There are 20 phases, right? For this icosahedron. So for these 20 phases, you know the shape of one phase, right? So all the phases are like, right, equilateral triangular shape. There are 20 phases, right? There are 20 phases for icosahedron. All of the 20 phases are equilateral triangular shaped phases. Alright, keep that in your mind. Alright. So the second one, please fill the blank. Alright, you have a blank. Please fill it. 20 phases. Then there are how many vertices for icosahedron? Right? There are 12 vertices. Yes. So Buddha, there are 12 vertices. Right. Then how many edges should be there? Just there. Yes. Super. So Buddha, you might have done this lesson in your school right now.
Sir, there are 30 vertices. Sorry, pages.
30 edges.
30 edges.
Yeah, edges. Right, there are 30 edges. And what is the fourth one? Normally we are writing the shape of a particular face. Right, the shape of a particular face. Normally we are writing that. Alright. So the all faces are in the shape of identical, right? Not identical regular pentagons. Please correct it as like this. Correct karagana.
Regular tetrahedron. Sorry, triangles.
Yes, that should be triangles. All faces are in the shape of right. I will write it here. Equilateral triangular shapes. Alright. Or you can write equilateral triangular shape of equilateral triangular, right? So these things are important. You need to remember. and 16, 16. Correct? So this is it. And we need to discuss about how to draw the net of the icosahedron as well. Right? How to draw the net of the icosahedron as well. Right? So the please correct these last two words in the fourth characteristic, right? In the page number 4, right? The characteristic of a regular icosahedron, right? Fourth one. Please correct it like this. Equilateral triangular. That is not identical regular pentagon. Please cut that 3 words. Instead of that, write in shape of equilateral triangular. Right? Yes. Farath is saying he is not having the first term exam. Yes. Some of the schools are having the exam, some of the schools are not. And if you have like and first term exam, you might have like 1 hour paper, right? Even for the grade 10, 11 Ayala also having 1 hour paper. I do not know, right? Okay, Nevinu is also not having the exam, right? Arivudi. So I hope you have written down this one. Alright. Now I am going to share the screen. Alright. So I will show you what is the shape of the icosahedron as well. Right. I am going to share the screen. Right. So this is dodecahedron that we discussed in last week. Right. So it has identical pentagon, regular pentagons for a shape of the face. Right. Then we are discussing about this one. So this is what we are discussed, right? This is called the icosahedron. Right. So you can see, right? Each and every face is like a triangular shape, right? All of them are equilateral triangular faces. Sorry, wait. Side, right? And this, and here, right? And here also same, right? All of the faces are equilateral triangular for icosahedron, and there are 20 faces are there. There are 20 faces are there for a icosahedron. Right. Now here also same. And this is the front view, right? This is the front view. And the back view also same thing, right? In the back view also you can see same thing for this icosahedron, right? So back view has been designed as like this dashed line. Can you see the dashed line here? So all the dashed lines represent the back view, the view that you cannot see. Right? Right. Everybody. So this is the view. Right? Right. This is the figure. Okay. Now we have done this instruction. Right? So then we have discussed this one, right? Regular icosahedron, and I told you to cut down these 3 words. Instead of that, I told you to write triangular, equilateral triangular shapes. Right? Okay, now we are going to discuss, or we are going to draw the net of the icosahedron. Right? Most of the times, they might ask from you to draw this one. In the exam, but I am for sure in this exam they will not ask. Right?
We haven't asked, sir.
What are they?
We haven't asked.
Yeah. Okay. So here I'll tell you the way to draw. I'll tell you the way to draw. Right? So, first of all, I will take my pencil and I will take my ruler. Right. So, first of all, what I am going to do is, right, I am going to draw 10 triangles in a row. Right? 10 triangles in a row. Right? So now look at the board, look at the screen. Right? So first of all, I will take these two quadrilaterals. Sorry. Now I will tell you as these quadrilaterals are like squares, right? These two rectangles, right? These two rectangles, and this is vertical length. And I am going to complete one triangle. Right? Then height will be 1, 2, 3, 4. Right? 1, 2, 3, 4. Right? 4 rectangles will be the height. Right? So please draw this triangle. Right? From here to here, there will be like 2 rectangles. The distance will be 2 rectangles from this end to this end. Right? Take it to the middle. Take it to the middle. Right? And somewhere around middle, you can begin drawing. හරි ඔයාලට පටන් ගන්න පුළුවන් draw කරන එක. පොඩ්ඩක් බලලා ගන්න. You need to have another 4 or 5 rectangles to the upper side as well, right? 1, 2, 3, 4, 5. Yes, I have 5. Right? You should have like at least 5. Alright, when you finish drawing, let me know. Send me D.
Random, sir.
Send me D for done. Or D, right, okay. So now, Buddha, I am going to continue this same triangle 5 times. I am going to continue this same triangle 5 times. Like this. To my right hand side, I am going to continue the same triangle until I get 5 triangles. Please draw. Like this. Right. So 1, 2, 3, 4, 5. Right. Okay. Now I am going to join these two vertices, right, on the top. Then again these two. Again these two. Again these two. Right. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9 triangles. So I have to complete another one at the end, like this. Right. Complete all 10 triangles and send me D. Complete all 10 triangles and send me D. Right. Super. Excellent. Right. So now I have 10 triangles and I told you there are 20 triangles. Now out of 20 I have drawn 10. Now where I should draw other 10
Down.
triangles. Right? So
Down.
yes, I will change the color to the red. So now I have on the top side here, right? Top side and below side. So Buddha, I can draw the rest of the 10 triangles, right? Like dividing 5 triangles on top, right? 5 triangles on top and 5 triangles in the border, right? Right. Where to draw? First of all, I will complete my first triangle on top like this. Right? So likewise, I can complete all my 5 triangles on top of this. Right? Now I have completed 15 triangles. Right? 15 triangles. And now how am I going to complete my 20 triangles? So below as well, I have to draw the same in the minimum. So this is the net of the right. So this is the net of the icosa head-drawn. Make a part easy to remember. Right? Now this is completed. Don't change your color, but I have changed the color because you can understand it very clearly. Right? Right. Hi. I hope you have drawn your other super. So Buddha, remember this one. Now there are 20 pages and you can draw the net of this like this. Remember? Right? In the middle, you have to draw right 10 triangles in a row. Then top, you have to draw 5 triangles. Then below, another 5 triangles. All together, you will be having like 10 triangles. Sorry, 20 triangles. Sorry. Right. Super. I am going to remove this. I'm going to remove that. Right. Okay. Now we are going to move. Okay, this one make a part easy. Right. So shall we fill this? Are we going to fill it? Exercise 6.1. Right. I will tell like this. A. Sa. Okay, right. I will say B. Tetra. Tetra. I will say C. Octagon. I'll say D. Triangular prism. I will say E. Today don't write. Huh? Look at the screen. Screen area. Right? I will say Q. Then I will say if octagon. Right. So they can't get drawn. Right? S. This is it. Right.
Sir, octagon no octahedron.
No, octagon, right? Not octahedron. Right? Right. And also, I will tell you another one. Cuboid. Right? Right. Okay. Now, I will ask from you. Right? Now, could you tell me? Right. What is the suitable? Right. What is the suitable letter? Right. What is the suitable letter from here? Right. For this one. When you make it,
G.
Yes. So super. It should be G. Right. Make a G. Right. So this is our cuboid. You need to fill it up with G. Right. And I am asking from Kaudabe. Devvar, Uday, can you tell me what is the suitable letter for second one? Suitable letter? Have they? D. Yes, D. It is D. Right? Make a D. Right. So I will cut D as well. So D එක cut කරන්න. Right. It is also gold. Then again E. C. See? The B the
B.
B. මට එන්නේ නැහැ. B for ball, right? Alright. So this should be B, yeah. Then this is not D. This is not the triangular prism, but it should be D. And then make a D window on it. Right? So this should be B. Yes, your answer is correct. Make a G. Alright. So this is called tetrahedron, right? Tetrahedron, right? So I will cancel this out. Our part B, right? So to the third part, can you tell me how Farah? Can you tell me the answer for the third one? What is the letter? Suitable letter here?
S.
Huh?
S.
F. Are you telling F?
Yes.
No. Wrong.
It is A.
No. Chirag, what should be the suitable letter here?
F. Sir, is it C?
Yeah, it is C. It is C. Where how many phases are there? 1, 2, 3, 4, 5, 6, 7, and 8. 8 phases. 8 equilateral triangular phases. The solid that we discussed in last week. Right? What is that? Octagon. Right? Octagon. So this is C. හරිද? ඔන්න මතක නැහැ හරි. මම නම් දන්නේ නැහැ හරි. මොකද කරන්න ඕනේ? මම අම්මලට කියන්න ඕනේද මේ මතක නැහැ පාඩම් කරලා නැහැ පොත බලලා නැහැ ටියුට් එක බලලවත් නැහැ කියලා. හරි. මට ඒකත් කරන්න පුළුවන්. හරි. Right. So they tell me how the yes Sina, what is the fourth one?
E.
Yes, it should be E. හරිද? මෙයා තමයි E. And then fifth one I will ask from Senoli. Kehatsa. Today, tell me what is V? What is the suitable letter for V? Suitable letter for this one. මෙන්න මෙයා. ඔව් මතක නැහැ. Grade 7 things are. මෙයා grade 7.
Kannai.
Kehatsa. Senoli. Today answer එක එවන්න හරි.
D.
Right. D. Yes, it is D. Right? What is the last one?
A.
A. Yes, A.
Because it has 20 phases.
Yes, it has 20 pages. Sorry, super. Right, Udin? So, I hope you have completed it by now, right? Right. Okay, now we are going to do this one. Right? I will come to the board and I will explain this one. Board I will explain karana. Right? What is this? Taylor's relationship for solids. We have learned that in now grade 7 as well. Right? Taylor's relationship. Okay, pronounce karna, right? Taylor's, right? So many pronunciations are there. Taviru, sorry. I saw your message now. Sorry, Uday. I will take you guys from next round now. Hi. Okay, Uday. So I will draw these things in the board. Right? First of all, shall we write the Taylor's relationship here? How the පුතා මේක ලියා ගන්න please කවුද අදිශ සරාරනේ පුතේ please write this. We are going to discuss the Taylor's relationship for solids. හරි මේක වට්ටම ලේසි. We have learned this one in our grade 7 maths. හරි
Is it right when it is right, like number of phases, number of edges, and number of vertices?
yeah. So පුතා please write this මෙන්න මෙහෙම. Right? If we add vertices plus faces, that means you have to add number of vertices. Number of vertices. Right? And if we add number of faces to that, right? Number of faces to that, it is equal to number of edges plus 2. Right? So please write this. This is the thing you need to remember. Number of vertices plus number of faces equals number of edges plus 2. Right? I will explain this in the board. First of all, please write this. Taylor's relationship, number of vertices plus number of faces plus equals number of edges plus 2. Right? Right. We can write this by using abbreviations as in. අපිට මේකට abbreviation use කරන්න පුළුවන්. Right? Number of vertices we are going to represent by V. Right? V. Then plus number of faces, we are going to represent number of faces by capital F. Then equal mark, right? Equal mark. Number of edges, number of edges we are going to represent by using capital E. Then we are going to add 2 to it. So V plus F is equal to E plus 2. Right? Vertices plus faces equals edges plus 2. Vertices plus faces equals edges plus 2. Right. Please write it. Right. Right. Okay. So now I am going to explain this table, right? Step by step. Right? I am coming to the board. I'm board here now. Alright. Okay. You have done it. Alright. Okay. Right. So let's do this. Right. First of all, I will clear the board. Right. So now we know what is our Euler's relationship? Right? I will write it again. Right? Euler's relationship. Right? So we are going to apply this Euler's relationship, right, for solids. We are going to apply this Euler's relationship for solids only. So this mathematician Euler, right? His name is Euler, right? So he has invented and he has introduced this relationship for particular solids. Right? So when we are adding number of vertices, right, and number of faces together, right, of a particular solid, right, we will get the answer like edges plus 2. Always it is correct. Correct. This Euler is saying if you take a particular solid and if you add vertices and faces, it will be equal to edges plus 2. Always it happens. He is saying that for a particular solid. Solid only, yeah. Alright. Keep that in your mind. Then next we are going to prove is it correct or wrong. Alright, for solids. Alright. So now let's do under page number 5. Right. This is under page number 5. So I have given you the Euler's relationship. Vertices plus number of faces is equal to number of edges plus 2. Alright, number of edges plus 2. Alright. Right. Then I have given you, let us fill the below table and check whether the Euler's relationship is satisfied or not. That means true or false. Alright. Let us fill the below table and check whether the Euler's relationship is true or false. Or satisfied or not. In the mathematical in the mathematical questions, right? Most of the times they will ask from you like satisfied or not, true or false, right? Those words can be there in your questions. Show this Euler's relationship is satisfying this solid icosahedron. Prove that. Show that. Right? එහෙම කියලා එන්න පුළුවන් question. හරිද? Right. Okay. So let's fill the table. I will draw the table here. අපි එතන අදින්න. Right. So our first column is solid. Right. Our first column is solid. Right. Here we have number of vertices. Here we have number of faces. Here we have number of edges. And here I have given vertices plus faces. Right? Then in the next one, I am having edges plus 2. Then I have asked you, Euler's relationship satisfied, yes or no? In the last column, I have asked Euler's relationship satisfied, yes or no? So now I have asked this one. Now this is my table. In the first place, I have asked regular octahedron, right? This is the first solid. Regular octahedron. Right? Right? Regular octahedron. Right? Regular octahedron. Right. Now it is your chance. Then all chance. There's the exam, they ask about this answer. Right. So then I will answer that question later. Right. So then, how the Chamiru? Now it is your time. Please fill V, F, and E. Can you tell me how many vertices are there for regular octahedron? Right?
6.
How many vertices? 6. Sorry. Yes. Then how many faces are there for a regular octahedron?
8.
8. How many edges are there for an octahedron?
12.
12. Nice. Right. So next one. Right. I am not going to fill the rest. I will first fill vertices, faces, and edges. Right. So my next solid is regular dodecahedron. Right. So who will get the chance to fill this one? V, F, and E? No one. Dayami. Have they?
Second I do.
Yeah. Tell me. Regular dodecahedron. How many vertices are there?
20.
Okay. 20. How many faces?
12.
Okay. Nice. How many edges?
30.
30. Super. Right. My next solid is regular equals hedron. Alright. Who get the chance to fill this? Vertices? Edges? Just wait.
20 faces.
12. Yes. Super. Faces?
Vertices. Faces 20.
Faces 20. Okay. Edges?
Edges 30.
30. Super. Right. Excellent. Hurry. Right. Okay. Then I am going to fill the 1, 2, 3, 4, fifth column. That is V plus F. Who is going to get the chance for filling V plus F of all the solids? Any volunteers? Chira?
18 regular octahedron.
Put a caddy mata. Dayami?
18 sir.
Right. Okay. Netmidi is saying, right? Okay. Right. V plus F. V plus F. What is the value here? V plus F. Vertices plus faces for regular octahedron.
14 sir.
14.
Yes, 40. Right. Nethula.
14.
Nethula. Tell me V plus F for regular dodecahedron. V plus F for regular dodecahedron.
32.
Huh?
32.
32. Right, Chanu 3. Please tell me for regular icosahedron what is V plus F?
32.
30. Super. Then E plus 2. How the Nevino. I was asking the question from Nevino, but he has sent me. No, he has sent me the answer for E plus F. Nevino, please tell me what is E plus 2 for regular octahedron. What is E? Right? Yes, your answer is correct, right? Same thing, mate. E plus 2, here we have the edges column, right? Here we have the edges column. So regular octahedron, right? We have 12 edges, right? We are going to add 2 to it. 12 plus 2, 14, right? 30 plus 2, 32. Again, we have for regular icosahedron, we have 30 edges and we are going to add 2. So 30 plus 2 again 32. Right? Right. Now what we have to do? Now all the columns except last one have been filled. All the columns, right, and rows except our last column has been filled out. Right? So now what we are going to do? What they are asking, Euler's relationship satisfied or not? Euler's relationship satisfied or not? Right. Yes. They are asking you to write yes or no for the first thing. Right? For the regular octahedron, is it satisfied? Right? Is your relationship is satisfied left hand side equal to right hand side or not? Okay? By looking at this one and this one. By looking at this one and this one. Right? So V plus F means left hand side. E plus 2 means right hand side. Mean left hand side, right hand side. They are asking Euler's relationship is satisfied. That means they are asking whether L equals R. They are asking whether you have to tell L equals R or not. Right? Yes or no. So L equals R or not. For all of them. Okay? Here you have V plus F 14. This one is also 14 and E plus 2 14. 14, 14. So the Euler's relationship is satisfied. It is true. Right? So this is yes. When it comes to regular dodecahedron, this is 32. That means our V plus F. That means our left hand side of the relationship 32 and also right hand side again 32. So equal. Right? Satisfied. Yes. And when it comes regular icosahedron, right? V plus F, left hand side of the relationship 32. Right hand side of the relationship, this 32. 32 equals 32. Doesn't matter. Our Euler's relationship is satisfied. Yes. Right? So now this is the complete table you need to know. Right? Make the complete table. Right? Please write it.
Can you state about my answer?
Alright, Netula is saying is all answers are correct. Super. Yes, Vival. I have a question. I was placed. They asked about if my answer is F plus E plus V. No, this is not similar to that one. It should be V plus F equals E plus 2. Then I wrote the total answer. Am I correct or wrong? If you write F plus E plus V plus 2, that is wrong. If you write this one, this relationship, that dot, right? Your answer is correct. Right. Okay, buddy. So now we are going to do. Alright. Shall we do some examples here? For example, like who has left? How they left? පුතේ මේ දවස්වල මේ හොඳ දරුවෝ වගේ වතුර බොන්න ඕනේ නේද? හරිද? වැඩිපුර වතුර බොන්න. right? වතුර බොන්න නැතුව ඉන්න එපා. right? Definitely drink water. හරිද? මේ නැත්තම් ඒ මාර එළියේ තියෙන රස්නෙට ඕගොල්ලන්ට එන අමාරු වෙන්න පුළුවන් මේ රැට. අනිවාර්යෙන් අම්මලට කියන්න ඔයාලා විතරක් නෙමෙයි. මලට තාත්තලට right? එළියේ වැඩ කරනවා නම් අනිවාර්යෙන් ඔය කැප්ස් අරවගෙන පළඳින්න ඕනේ. හරිද? නැත්තම් එන ඩේන්ජර් දැන් මේ දවස්වල හරි. right. So I have shared the screen. Exercise 6.2. හරිද? මේක. Exercise 6.2. Verify users අපි මොකද කරන්නේ? Right. Let's do this. අපි මේක කරමු. හරි? Let's do fourth one. Right. Can you guys give it a try to do? මෙන්න මේක කරන්න try එකක් දෙන්න පුළුවන්. Fourth one. Related to this. I will zoom this. මම මේක zoom කරනවා. Right? So that you can see it clearly. Right? This is the question. Right? This is the related solid. The figure of a composite solid is shown here. That is this. Right? On top of the cube, you have square pyramid. Right? On top of the cube, you have a square pyramid. Then determine with reasons whether Euler's relationship is satisfied for this solid. You have to show whether it is satisfied or it is not satisfied. So Euler's relationship is this. You need to write the Euler's relationship first. Alright, I will let you know the steps. Right? V plus F equals to E plus 2. Puthala, this is the Euler's relationship. Then you need to find separately. Alright, you need to find separately what is the number of vertices, right? What is the number of faces, right? What is the number of edges, right? Then what is the what is the number of edges? Then you have to take vertices plus f, that is your left hand side of the equation, right? Equals, okay, everyone has sent me the answer, right? Then you have to find you have to do little bit different, right? Answer. Then you have to find E plus 2. Then you need to compare these two are equal, no. Then say, right, V plus F equals this, E plus 2 equals this. So this is satisfied or not satisfied. And this is the way you are going to do. First of all, write the Euler's relationship like this. And I am helping you. This is what you are going to do first. Then find vertices, faces, and edges separate. Then find V plus F separately. Then find E plus 2 separately. Then explain your Euler's relationship is satisfied or not for this. Sorry. Right? And send me the answer to the chat on Mamewa V plus F and the answer for E plus 2. I want to see who finishes first, right? And I want to see who finishes first and send me the V plus F and E plus 2's value. Right? Send me both answers, p plus f and e plus 2. I need to see who finishes first. මට බලන්න කවුද වලට ඉවර ගන්න කියලා. ඔන්න ඔය දෙකට answers ටික මට chat එකට දාන්න ටක්කා. Using a single message you can type. For b plus f you will get, like for an example, 5,000. Comma e plus 2 you will get 6,000. මෙන්න මෙහෙම. මෙච්චරෙන් නෑ හරි. This is for an example lah. Right, Neville has sent me. Okay, Neville got the first place. Superb. Gayumi, yes, got the right. Right, what about others? Well, you have to just count that. You need to count. Right? The count is an argument I count. Everything. Do it fast. Make a lying current. Right. First place got the Nevinu. Second place got Gayumi. Third place Sinara. Is it equal or different? Right. Okay, super. Hirusha. Hirusha. Subject of birthday पर नतुई जरा गल्ला जाम मनी. Tavi, super. Yes, sir. मुझे अनित एक मडे वरना. B plus F. Yes, B plus F. Oh, देखिए ना शेर. चार yes.
අපි වෙන වෙනමද ගන්නෙ ඒ කියන්නේ කියුබ් එකේ මේ v plus f වෙනමද ගන්නෙ
No. You have to count all of the things together. Right? Now this is a composite term. Combine. Composite solid. හරිද? ඒ කියන්නේ these there are two solids and they have been pasted together. Right? They have been pasted together. එකට අලවලා තියෙන්නේ. On top of each other. Right? So now this is one solid. So you have to count all vertices, faces and edges as one solid. Right? Right.
yes.
Alright. Yes, Nebula, send me. I know you have ended up. Right? Yes, good. Right. Shall I discuss? Want to discuss karanga? Alright. I will come to the board. On board I will draw it in the board and I will let you know. Yeah. Right. So now focus on the board. Don't do anything. Good karanne ba. Alright. Focus on the board. Right. So I'm going to explain this step by step. Okay. This kind of question can be in your exam. They might ask from you. Right? They are asking determine with the reasons whether Euler's relationship is satisfied or not for this solid. So this is a composite solid, right? That means they have combined, right, and pasted together few solids, right, so that you can figure it out as a one solid. So for that one solid you have to calculate all the things. Right. So now focus on the board. Right. I will do this. So you have to follow the same steps. You have to follow the same steps. Alright. So we are doing exercise 6.2, exercise 6.2, fourth question, under page number 6. Right? Page number 6, exercise 6.2, fourth question. Right? So here we have a figure of a composite solid is shown here. Right? Determined with reasons whether Euler's relationship is satisfied or not for this solid. Right? I will draw the solid first. Not solid day again. Right. I will draw the solid here. So this is the cube. Right? And top of this cube you have a square pyramid. Right? Right. So it is something like this. Right. So now I will take my red pen. And what I told you earlier is from a cube A, right? First of all, you may, right, it would be better if you can write the Euler's relationship. Right? So our Euler's relationship is vertices plus faces equals edges plus 2. Right? So now I am going to calculate vertices, faces, and edges separately. Right? So I will do this one first. I'll make a right? So vertices, number of vertices. I am going to round, or I am going to circle the vertices. Right? 1, 2, 3, 4, 5, 6, 7, 8. On top of this, 9. There are 9 vertices. So Buddha, your answer is correct. Number of vertices are 9. Now I am going to calculate the number of faces that we are having. Now you know, on top of this you have a square pyramid, right? Square pyramid, right? Here we have, right, around this one, right? Gisahi pyramid, right? If we go around the pyramid, we have 4 equilateral triangles, triangular shaped faces. First one, second one, and their backside, third one, and this side, fourth one. Right? On top of this, we have 4 faces. And here in the cube, we have 5 faces. 1, 2, 3, 4, and the below one is 5. Right? So here we have 5 faces in the cube. On top of this, you have 4 faces. 5 plus 4, 9. Altogether, we have 9 faces for the composite solid. Complete solid. Right? Then edges are number of edges. So I'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right? So we have 16 edges. Right? We have 16 edges. Right? 9 vertices, 9 faces, 16 edges. Right. So now I am going to show whether my left hand side equals to right hand side. So that means if those values are equal together, Euler's relationship will be satisfied. If they are different, not satisfied. Right? What I see. So first of all, I will find V plus F. Vertices plus faces. 9 plus 9. 9 plus 9 equals 18. Then I will take E plus 2. E plus 2 means E means edges 16 plus 2. 18. Superb. Make 18, 18. V plus F. E plus 2. 18, 18. So they are equal. So we can write. Therefore, V plus F equals E plus 2. The Euler's relationship. The Euler's relationship is satisfied. Is satisfied. So Buddha, it would be better if you can follow the same steps. Make a patta clear. This is patta clear. Very clear and very simple. Right? Very simple thing you have to follow. Right? Normally we are doing same thing in the mathematical question as well. Right? When you are going to grade 10 and 11, right? It would be better if you can use this way. Don't use other ways. This is a proper systematic way. Make a niyama method. Systematic විදිය. හරිද පුතේ? හරි. So the understood this one මේක තේරුණාද up to now? Do you have any questions? Right. Y එකක් දාන්න තේරුණා නම් please. If you have any questions you can ask from me. තේරුණා you can put a Y or you can ask from me any question. Right. So then just send me Y. A. Hi. Okay. Super. Hi. Hari. Okay. Now we are going to have the break. Right. Abhi, let's have like 5-minute break. ඇතිනේ. අපි වැඩි ඕනේ නැහැ නාස්ති කරන්න. හෙට නිවාඩුනේ නේද? So you can have a good sleep today, right? Because tomorrow is a holiday. සමහර කට්ටිය බ්‍රහස්පතින්දා යන්නෙත් නැතුව ඉස්කෝලේ. ඇයි සිකුරාදා නිවාඩුනේ? නේද? Right. Today now 7:22. Let's meet at 7:27. Sorry, 7:28 අපි හම්බෙමු ඉවරට. Right. Let's meet at 7:28. Right. So do the sixth one. Right. The figure given here shows a pyramid which upper portion has been cut out and removed. Right. Verify the Euler's relationship for this solid. Right. With the solid. So you have to just send me whether it is satisfied or not. Yes or no. Yes. Never have sent me the answer. He is saying yes. Let's see everyone. Hirosha is also saying yes. Netmita is also saying yes. Chaviru is saying yes. Gayumi, okay. I am receiving only yeses, ne? Right. See, yes. Janani is saying yes. Parat, yes. Okay. Devha, okay. Right. Okay. So it look like very easy, ne? So I will do it in the board, on the board. Now pay your 100% attention on the board. Correct? What is ever. Right. I'm going to do it step by step. Right? Okay. Page number 6. Exercise 6.2. Sixth question. Right? Sixth question is saying the figure given here shows a pyramid thing, right? And of which the upper portion has been cut out and removed so that you have a something like here in the middle, right? I will draw it here. Ready? So this is originally a pyramid. Make a originally a pyramid like this, square pyramid like this. And but it's saying a upper part has been cut out in a way. So it becomes like this. So it becomes something like this. So now you have this. The upper portion has been cut. Right? Right. So now here you have this solid. Now this is the solid you are going to deal with. Alright? Right. So now they are asking verify Euler's relationship for this solid. You need to verify the Euler's relationship for this one. First of all, I would write the Euler's relationship. V plus F equals Hs plus 2. So I am going to find the number of vertices. I am going to find the number of faces. I am going to find the number of edges. Equal mark, equal mark, equal mark. So number of vertices, right? I am going to count. Right? I am going to count. So here 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 vertices. Faces, below I have 1. Top I have 1. So 1 plus 1, 2. Here I have 3, 4, back 5. There, right? Around this 6. So all together we have 6 faces. How many edges are there? Right. I am going to count it. Right? Don't tabulate so that I am using my pencil and I am marking it so that I won't get any duplication count. Duplicate pen so that I am using my pencil to cut it small. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges. Right? There are 12 edges. Right. So this is my Euler's relationship. So this is my left hand side. This is my right hand side. So the V plus F. V plus F equals 8 plus 6. 8 plus 6 equals 40. Okay. right hand side e plus 2. E plus 2 edges are 12 plus 2. 14. Nice. Super. Okay. 14 and 14. So you can write, therefore, P plus F vertices plus number of faces equals edges plus 2. Right. So we can write Euler's. I'm not going to write all the thing. Euler's relationship is satisfied. Right? So that this is the answer. Right. Okay. Now, right. I'm going to clear the book. Right. Now we are going to discuss about the platonic solids. Right? Platonic solids. What are called platonic solids? What are they? What are they? What are they? You know already. Right? Platonic solids, you know. So the very basically you need to remember this. Very basically you need to remember this when it comes to the platonic solid. Alright. So the right. So normally when we are going to refer platonic solid as this. I will draw. First of all, I will draw a platonic solid so that you can understand. Right. And if we draw our tetrahedron, right? If we draw our tetrahedron, right? So normally, if we consider this vertex, right? If we consider this vertex, right? How many faces are combined with this vertex? Right? How many number of faces are combined with this vertex? Right? That is the thing you need to understand. Right? How many identical faces? Right? How many identical faces are combined with this vertex? So normally for a tetrahedron, right? If we consider this vertex, we have one face, and below we have another face, this one, and backward we have another face. How many faces are there? Now three faces, three identical faces. Faces meeting at this vertex. Three identical faces. Huh? And if we consider this vertex, how many identical faces are meeting at this vertex? Let's count. This face, 1. This face, 2. And the below face. 3 faces, sir. 3 identical faces. Here also 3 identical faces are meeting at this vertex. And for this vertex as well, for a tetrahedron, 3 identical faces. Right. So let's count the number of faces for this vertex. Now look at the board. Now I am explaining. This is the first phase. And here we have the other phase, the below one. And around this, right? Here we have the other one. Right? Here, this side, if we look at from this side, right, around, right? This is the other phase that we are meeting. That meets this vertex. So all together 1, 2, 3. 3 identical faces. Right. For this vertex, 3 identical faces. For this vertex, 3 identical faces. For this vertex, also 3 identical faces. You know what is identical faces? What is the shape of the identical faces? That is triangular. Right? Triangular faces mean 3 identical triangular faces meeting at this vertex with this vertex and this vertex. Let's check the top one, this one. Now we are going to check whether how many identical triangular faces are meeting at this vertex. This is one of the face. 1. And the other one is this 2. And back we have 3. Again 3 identical faces. 3 identical triangular faces. I will write it like this here now. Right? So Buddha, each and every vertex, right? For each and every vertex, there are 3 identical triangular faces, right? Meeting at each and every vertex there are 3 identical triangular faces, right? So we can get an idea about platonic solids, right? So normally platonic solids are called, right, if the number of faces meeting at the each and every vertex, and those faces should be very identical. First property is same number of faces. Second property is those faces should be identical, right? For each and every vertex, number of faces, and those faces should be very identical each other, right? Then, right, we call this solid is a platonic solid. So for this vertex, 3 identical triangular faces are meeting at this one. If we consider this vertex, 3 identical triangular faces are meeting at this point, right? If we consider this 3 identical, this one 3 identical vertical faces. Each and every vertex we have same number of identical faces. Same number of identical faces. Alright? Keep that in your mind. Same number of identical faces. Keep that in your mind. When you are going to the exam. Alright? Super. Yeah. So the what I unclear right? Now is it okay? Is it unclear?
Sir, the board is clear, sir.
Clear?
Yes.
Okay. Alright. Now this is for this one. Now I am going to explain it again. Right. So I will take my cube. I will draw a cube. Alright. So this is my cube. Alright, make my cube. Alright. So this is my cube. Now, first of all, I am going to consider my. I will take one of the vertex. I will take this maker. Right. Right. So here now I am going to count how many faces are meeting at this vertex. And we know the shape of this vertex. Sorry, shape of this face. What is the shape of face of a cube? Can anyone tell me what is the shape of a face of a cube? What is the shape of the
Rectangle.
cube?
Square.
Square.
I guess rectangle square ne? Right? It should be square. Yes, Budi. Yes, Sana. Yes, it's a square. May make a rectangle, but I am asking about a cube. May make a rectangle of Vela. No, I am not going to fix that. So I am going to count the number of faces which meets at this point. Right? Okay. So this is one of the faces. Maybe one face. And this total face, it is 1. Then on top, this one. 3. Sorry, 2. Now this one. This is another total face. So how many faces are there? Right? Meeting at this vertex. 1, 2, 3. 3 faces. Right? I will write it like this. 3 identical square faces. Right? We are going to check same thing for this vertex, this vertex, this vertex, this all. Well, I will take this. Right? Alright. This is one face. Right? Front view, one face. Below, we have another one. Another one. And side, right, back way, we have another one. So all together, 1, 2, 3. 3 identical square faces. And for this one, 1, 2, below 1, 3. 3 identical square faces. This one is 1. And the back one, 2. Below one, 3. 3 identical square faces. Each and everywhere you have 3 identical square faces. For this one, for this one, for this one, right? For this one as well, right? Each and everywhere you are having same number of identical square faces for a cube as well. So we are calling this cube is a platonic solid. And as well as that, we are calling this tetrahedron is a platonic solid. Right? So because we have identical number of faces meeting at each and every vertex. For each and every vertex, right? Identical number of faces are meeting at each and every vertex. Keep that in your mind. Right? If that happens, right, we are calling those solids are platonic solids. Right? Platonic solids. I think now you have like 60% idea about platonic solids. That is enough. Let's do the rest. Alright, right. Page number 6. Page number 6. fifth subtitle, platonic solids. Platonic solids. Alright. Right. So first of all, let's write what is a platonic solid. And I have given you an little bit of introduction, right? What is called a platonic solid? What is a platonic solid? Right? What is a platonic solid? Right? So let's write it together. අපි එකටම ලියමු. Right. Platonic solids are, right? Platonic solids are platonic solids are solids having, right? Solids having, right? Regular polygonal faces. Wait, I will change the color. Regular, make a what important word, right? You need to remember. Platonic solids are solids having regular polygonal faces, right? Regular polygonal faces. So the regular polygonal faces means identical faces. Inside the brackets, I will write identical faces so that you can understand. Correct? Inside brackets, I will write identical faces. Faces. Identical faces. And with, right? And with the same number of faces, right? And with the same number of faces. I'm changing the color. These words are very important. Same number of faces. So these are very important, right? Identical faces you should have. Same number of faces you should have. So you need to remember that. Right. So I will.
So after the regular polygon,
Yes.
that is polygon.
Polygonal faces, right? Regular. I am writing it, rewriting it again, right? Regular polygonal faces, right? Regular polygonal faces. I hope you can see now. Hurry.
Yes, sir.
So now these are same. You can remember it whatever you want. Regular polygonal faces or identical faces, right? Identical faces means, right? Like think of twins, right? Twins like anything හරියටම identical නෑ, but think of for twin, right? So you cannot differentiate them නේද? ඒගොල්ලන්ව වෙන් කරගන්න බෑ.
Right, sir.
Right? So they are same, identical. Ade, who is Ayya, who is Malli? Right? Oh, who is Sumudu, who is Kumudu? Right? We do not know. Right? Right. So now this is the thing you need to remember. These are the two things that is very important. There should be identical faces and same number of faces meeting at each and every vertex, right? Same number of faces, right, at every vertex. Or maybe faces at every vertex. So each and every vertex should have identical faces, and those faces should be equal, same number of faces. That means identical number of faces should be meet at each and every vertex, so that it will call a platonic solid. Correct? Right. Hurry. There is an important point you need to remember. So I have given you. Okay.
Sir, there will be questions to write definitions of this, like write the definition of
Yes.
platonic solids.
Yes. That's why I told you need to remember these two. Sometimes in the exam they might ask what is called a platonic solid. You have to write, right? Platonic solids are called, right? Are called solids having identical faces with the same number of faces at every vertex. At every vertex, right? Identical number of faces meeting at every vertex, right? Shall I write my definition? My definition name only. So it will be very easier. But if you can remember this one, that is okay. Yeah, right. I will give the brief one, right? Identical number of faces must meet at every vertex. At every vertex of platonic solids. Platonic solids. Alright. So Uda, I have given this fact and this fact by using single word, right? Single sentence, right? Identical, right? Identical, same number of faces, right? Like all the things are here. Okay, right. So the important point you need to remember, important point. Right. What is this important point you need to remember? I have given you some like figures, right, in the below, right? I am going to write it by using the sentence here, right? Regular tetrahedron, cube, regular octahedron, right? Regular dodecahedron and regular icosahedron. All of them are platonic solids. All of them are platonic solids, right? So I will write it here, right? Regular tetrahedron, regular. Please write with me. Hari මේක මාත් එක්ක ලියගන්න. Tetrahedron, comma, cube, comma, regular octahedron, comma, right, regular dodecahedron, right? Regular dodecahedron, comma, right? No, not comma, and regular icosahedron. Icosahedron are all platonic solids. Are all platonic solids. Right? Right. Right. Now, I am going to share the screen with you. Right. So please write this one. මේක ලියා ගන්න. These are the things that I have given you. Right. Under important point, I have given you this regular tetrahedron, which is this. Right? Then cube. Then I gave you regular octahedron. Right? Then I gave you regular dodecahedron. Then I gave you regular icosahedron. Why did I told you that? Shall I show you? I will clear them and I will zoom this. Make a zoom so that you can see it clearly. So when you are considering the regular tetrahedron, right? I am going to consider this vertex. Right? Now I am going to mark number of faces meet at this vertex. Right? Meet at this vertex. Then I will put a mark. Right? So this is my first face, this is my second one, this is my third face. Right? So 3 faces, all the faces are triangular shaped faces. And if I consider this vertex, this is the first face, this is the second face, and below the other side I have third face. So likewise, each and every vertex is having 3 identical, right, regular triangular shapes, right, identical shapes, right. Cube, if I consider this vertex, this is the first face, second face, third face. There are 3 faces meeting at this vertex. And all of these faces are identical square faces. And if you consider this vertex, first face, second face, and below you have third phase. This side. Right? Each and every vertex, if you count, there are 3 identical square faces meeting at each and every vertex. Are the right? And if you consider regular octahedron, right? What is the shape of the regular octahedron? When someone is asking from you, what is the shape of the regular octahedron? Regular octahedron. What you need to give the answer? What you need to give as the answer? Huh?
Regular tetrahedron.
Regular?
Tetrahedron.
No. Shape of a face of a regular octahedron. I am asking, what is the shape?
Equilateral triangle. Regular.
Super. Right? That is the perfect answer for, right? When someone is asking from you, write down what is the shape of regular octahedron. You need to write it as equilateral, right? Equilateral triangular shape, right? Equilateral, right? Triangular shape. All of these triangles are identical, equilateral, right? Right. So I will consider this top one, top vertex. Now I'm going to count the faces. Phase 1, phase 2, phase 3, and the other one around this, right? Maybe it was in the back way, right? That is the 4th phase, right? And if you consider this vertex, first phase, second phase, third phase, and around this you have 4th phase, right? So on and so forth. Each and every vertex meeting identical equilateral 4 triangles, regular dodecahedron. So you have pentagons, regular pentagons, each and every vertex, right here 1, 2, 3. Here 1, 2, 3. Same number of faces. Each and every face is regular pentagon. If you consider this 1, 2, 3. If you consider this vertex 1, 2, 3. Right? If you consider this vertex 1, 2, 3. Right? Each and everywhere you are having 3 identical pentagons. Are the right? I'll clear this. Right. Then what about the icosahedron? Nice. So if we consider this vertex, how many identical triangular faces are there? 1, 2, 3, 4, 5. Right. If we consider this vertex, 1, 2, 3, 4. Where is 5? It is in the back side. Right. If we consider this vertex, 1, 2, 3, 4. What is the other? Here, the back side. Right. 5. Right. 5 identical equilateral triangular faces are meeting at each and every vertex. So it becomes a platonic solid. This is a platonic solid, this is a platonic solid, this is a platonic solid, dodecahedron platonic solid, icosahedron platonic solid. Are you right? So ඔය ඔය ටික පාඩම් කරගන්න. හරිද? ඔය මොනවද? Introductions ටික, right? Descriptions ටික. Right. Right. I will do this one. Right? I will do the cube and cuboid. Right? In the exercise 6.3. Right? In exercise 6.3. Right? So you have to do the other things at home. Right? Other things at home. You are to ගෙදරදී කරන්න යන ඉතුරු ටික. හරිද? පුතේ මේ අර අලුත් පුතාට මම මේක එවන්න. හරි? මේ හරි. අලුත් පුතාට මම මේක එවන්නම් මේ you can do it at the home. හරිද? So this is exercise 6.3. Right? I will fill cube and cuboid. I need your support to complete this one, right? මට ඔයාලගේ support එක ඕනේ to fill this one. Right. Okay. Right. I will take the cube first. Right. I will take the cube. Right. In the first column, you have to fill shapes of the faces of the solid. Right. Shape of the faces of the solid. Right.
That is square.
Yes. Shape is square, right? Super. I will write here square. Right? Now tell me, are all the faces regular or
Yes.
identical? Right?
Regular, sir.
Regular, right? So it is identical, right? Yes. So you have to write yes. Then yes. Are the number of faces meeting at each vertex equal? Right? If you consider cube,
Yes, sir.
should be yes. So this is something like a cube, right? And I have given you at this under important point. Another important point I have given, right? So are the number of faces meeting at each and every vertex is equal? Yes. 1, 2, 3, right? Yes. Tumda, yes. It is 3, right? Number of faces meeting at a vertex? 3. Is this solid a platonic solid? Yes or no? Yes.
Yes.
Yes, super. Right. Now we are going to do cuboid. Cuboid. Right. Shapes of the faces of the solid.
Like rectangle.
Rectangles. Okay. Are all the faces regular?
No.
No.
Right? No. Are the number of faces meeting at each and every vertex equal?
Yes. No. No.
No.
No. It should be yes. Why is that? It is very similar to cube. Right? It is very similar to cube. This is my rectangle. Right?
Yes.
Yes. This should be yes. This is my cube. I have dragged it. Elastic so that it becomes a cuboid. I have dragged this one to this one, right? What the shape of the faces are changed. I am hearing a noise. Are you counting the number of faces? Right? So here, if we consider this vertex today, this is 1, 2, 3. There are 3 faces. If we consider this vertex, 1, 2, the other side is 3, right? So the answer should be 3. Yes. Is that the platonic solid rectangle?
No.
No.
Why is that? Hey,
Because the shapes are not regular.
super. Because the shape is not regular. When the are not regular. This is no. Right? Excellent. Alright. So is the solid a platonic solid? No. Right? So if both of the right, if both of the columns here are yes, then it is a platonic solid, right? If one of these is no, right? If one of these is no, then it is not a platonic solid. Right? So that is the way you are going to identify. Are you there? So 6.3 and the mixed size of the tube is homework. හරිද? මේක තේරුණාද? Did you understand this one? මේක තේරුණාද? Any questions? මොනවද ප්‍රශ්න තියෙනවද? Tell me. If you have any questions from this one, you can say yes. You can send me yes. Right? If you have no questions, you can say no. Right. Okay. Hope you got this. Okay, no questions, right? Super. Hi. Okay, boys and girls, right? We are going to end this like solids lesson here. අපි මෙතන මේක ඉවර කරනවා. Right? And පුතේ මේ අලුත් අයට